Okay, this is section 7 in chapter 2, continuing our look at limits and the derivatives, specifically looking at applications of business, looking at marginal analysis in business and economics. Okay, as we go through this section, it's really important that you understand when you see the word marginal. Marginal means the instantaneous rate of change. So when we talk about marginal cost, that's the instantaneous rate of change of the cost. And if we do marginal profit, that's the instantaneous rate of change of the profit. Or in other words, how is the profit changing at a particular point in time? So anytime you see the word marginal, take the derivative. Okay, so whatever marginal is in front of, that's what you're going to take the derivative of. Okay, so a few notations and formulas that you need to be familiar with. So X is going to always represent the number of units that we're talking about. So the number of units being produced and sold, okay? So the capital C or C of X represents the total cost. So if you wanted to produce 10 items, what's the total cost to produce those 10 items? That's your total cost. Marginal, there's that word marginal, cost is the derivative of cost. So it's C prime of X. Revenue, total revenue, we denote with a capital R, so R of X. Marginal, when we put the word marginal in front of it, then it's the derivative of revenue, so R prime of X. Profit is capital P of X. We've seen like a lowercase p of X and then a capital P. So lowercase p is price, like a price per unit. Capital P is profit. The profit is always the revenue that's generated minus the cost. So if you do revenue minus cost, it gives you the profit. Marginal profit just means the derivative of the profit equation, or another way to think of it is the derivative of revenue minus the derivative of cost, or marginal revenue minus marginal cost. It is so important that you understand these relationships here because we will continue to use them throughout the semester and on beyond in your particular major. Okay, so we've already said marginal cost is the instantaneous rate of change of cost relative to production at a given production level. Okay, so we have to have a specific point in time to be able to get that instantaneous rate of change. So that, and when I say point in time, I'm usually referring to like number of units being produced, like 100 units being produced, 500 units being produced. Okay, so we want to compare marginal cost and exact cost. So it says, suppose C of X, which is the total cost of producing X items. So we want to find the exact additional cost of producing one more item. Okay, so for instance, if I wanted to know what the cost of producing the 10th item, if I'm already producing 9 items, that's kind of what it's talking about. So like maybe for instance, if X is 9, then you're looking at, if you want to find the exact additional cost of producing one more item when you've already produced 9, then you're going to find the cost of producing the 10th one, subtract from it the cost of producing the 9th one, and that's going to give you the exact additional cost of producing one more item. And that does transfer for revenue and profit. So the additional revenue, one more additional revenue, it would be R of X plus 1 minus R of X. Same thing with profit. Okay, so let's look at an example here. We've got a company manufactures fuel tanks for cars. The total weekly cost in dollars of producing X tanks is given by this cost equation. So this is our total cost. So if I plugged in 5, then that's going to give me the total cost of producing 5 tanks, for fuel tanks for cars. Okay, so we want to find the marginal cost function. So not at a particular place, but the equation of it. So marginal means derivative. So I'm going to find the derivative of cost function. Okay, so the derivative of 10,000, that's a constant, so that's going to be 0. The derivative of 90x would just be 90. And then the derivative over here would be the 0.05 times the derivative of x squared, which would be 2x. So it's going to be 90 minus 0. 0.05 times 2 would be 0.1 times x. Okay, so now it says find the marginal cost at a production level of 500 tanks per week. Okay, so no longer do we want it to be like a general formula. We want a specific value when X is 500. Okay, and we want the marginal cost. Well, we just found the formula or the function for marginal cost. So that's going to be 90 minus 0.1x. So if I want the marginal cost when 500 units are being produced, then I'm just going to plug 500 into the marginal cost equation. And I'll do that calculation. And it looks like I'm going to get 40. And so what that is it's $40 per tank. Okay. So the cost is changing at a level of production of 500 tanks. It's 500 tanks per week is changing at $40 per tank. Okay, so as far as what I want you to be able to write, it doesn't have to be word for word, but it should have the same intent. So you need to state your production level. So at a production level of 500 tanks per week, the total production costs, because we're talking about cost here, total production costs are increasing. Our marginal cost was positive, so we know it's increasing at the rate of $40 per tank. Okay, so that would be the type of interpretation I would want you to be able to give. Okay, so basically, since the cost is changing at about $40 per unit, and at a level of production of 500 tanks per week, that's how much it would cost to make another additional unit. Then the 501st tank is going to cost about $40. So what happens is the marginal cost actually gives an approximation on what it's going to cost to make the next item. Okay. So when it asks us to find the exact cost of producing the 501st tank, the exact cost, we're going to do the cost of the 501st tank minus the cost of the 500th tank. And that's going to give us the exact cost to produce that 501st tank. So when I plug that in, if I come up here, see of the cost for 501, I'm just going to plug that in. And it looks like I'm going to get 42,539.95. And do the same thing for 500, and you're going to get 42,500. So that's the two numbers that I'm going to subtract. So I'm going to take the cost for 501. Keep in mind that that's the total cost. So that this 42,000 is the total cost to produce 501 units. It's not the cost to produce the 501st unit itself. Okay, that's what we're doing here when we subtract these. Okay, so when I subtract those, I'm going to get $39.95. So the exact cost to produce 501 fuel tanks, when I've already produced 500 fuel tanks, is $39.95. Now, if we go back, we saw that the marginal cost was an estimate for what it cost to make that 501st tank. And we said that was $40. So $40 is actually a very good estimate for this, which was $39.95. Okay, so what we have is the tangent line is representing the marginal cost. Okay, so at a particular point, and then the exact cost is this function here. Okay, so what we see is we actually see that there's a difference in here between the two values. So there are times when the marginal cost could be an overestimate, and there's times when it could be an underestimate. This particular one, the marginal cost is going to be an overestimate because it's above the actual line here. But if our function had done something like this, okay, then our tangent line would have been here, and so our tangent line would have actually been an underestimate instead of an overestimate. Okay, so the marginal cost function approximates the exact cost of producing the x plus 1 item, okay? So anytime on like your homework you're asked to give an approximation, and it's wanting you to use the marginal function. Okay, so we've got an example here. The exact cost of find the exact cost of producing the 121st bicycle. So I'm going to go through these pretty quickly because it's really just another example of what we've already done. So we would need to find the exact cost. So exact cost is going to be the cost of producing the 121st minus the cost of producing the 120th. So the cost of producing the 121st, if I plug into this cost function, is going to be the $25,221.80. I need to do the same thing with the cost of producing the 120 bicycles. And then I need to subtract those. And so what I see is the exact cost is $101.80. Okay, use the marginal cost to approximate the cost of producing the 121st bicycle. Okay, so when we have something like this, what we're going to do, marginal tells us we need to work with the derivative. So I'm going to take the derivative, and that's going to be 150 minus 0.4x. If we want to approximate the cost of the 121st bicycle, we actually need to put the 120th in to this, because what this is going to tell me is if we're already producing 120, how much does it cost to produce 121st, and which is what we're asked to find here. So we're going to do 150 minus 0.4 times 120, and when you put that in, you're going to see that that's $102. Okay, so our estimate is $102, and the exact was $101.80. Okay, so again, it's a good approximation. Okay, this example is talking about production strategy. So a company's market research department recommends to the manufacturer and marketing of a new headphone. The research department presents the following price demand equation. Okay, so the research department gives us this equation here, and that's called our price demand equation because it actually relates how the demand, which is X, is going to change as the price changes. So we know that like if the price goes up, the demand might go down and so forth. So it's important to know that relationship there. So we want to take this equation and solve this for price as a function of demand. So same equation, we just want it to be solved for P instead of X. So the first thing I'm going to do is I'm going to subtract this 10,000 from both sides. So I'm going to have X minus 10,000 is equal to negative 1,000 P. Okay, I'm going to come over here to the side and I'm going to divide both sides by this negative 1,000. So I get the P by itself. Okay, so I'm going to get that 1,000 gone there. Don't divide by the P. I shouldn't have written a P there. Okay, so we're left with P on the right side, and on the left side, we've got X minus 10,000 over negative 1,000. So we're going to break it up like we've done before and put everything over the denominator. So I'm going to have X over negative 1,000, and then two negatives make a positive, and 10,000 divided by 1,000 is going to be plus 10. If you don't want to work with it as a fraction, you can go ahead and do 1 divided by 1,000. Okay, and so that's going to give me negative 0.001x. Okay, so this is the price demand equation solved for price as a function of demand. So that's what we're first asked to come up with. Okay, find the domain of the function defined by the price demand equation. Well, if we're looking up here, what happens is when we're talking about domain, our domain, we've got to have a positive number of units and a positive price. So not only does x have to be greater than or equal to 0, p also needs to be greater than or equal to 0. We figured out that p is equal to this equation here, so that means the 10 minus 0.001x needs to be greater than or equal to 0. So I'm going to solve this for x now, which means taking the 10 to the other side, then dividing by negative 0.001. So x is going to be greater than or equal, actually less than or equal to, we need to switch it because we're switching that, we're dividing by negative, so we need to switch that inequality. So x is going to be less than or equal to, and if I divide 10 by 0.001, then that's going to be 10,000. So x needs to be greater than or equal to 0, and it also needs to be less than or equal to 10,000 for this equation to work. Okay, so continuing with this same problem that we started, we're also given from the finance department the cost function. So the cost function is 7,000 plus 2x. So 7,000 would represent our fixed cost, and the 2x is representing the variable cost per headphone. So we want to find and interpret the marginal cost function. So marginal cost, marginal means derivative. We're going to take the derivative of the cost function. So if I take the derivative of 7,000, that's just 0. And if I take the derivative of 2x, then that's going to be 2. Okay, so what we see is that the marginal cost is 2 regardless of what the x is, because it stays constant. So as far as interpreting it, like we said, the marginal cost is 2, so it's a constant, so it costs an additional $2 to produce one more headphone at any production level. So basically, if I was producing 10 or 100 or 1,000 or even up to 10,000, the additional cost is just going to be $2. So it's not really based upon the number of items being produced when it's a constant like that. Okay, so we want to take all this information that we found and find the revenue function. So if you recall, revenue is the price times the number of items that's being sold. Okay, so we have our price function here. Price is the lowercase p, so that's going to be 10 minus 0.001x. That goes in the place of the p here, and then I have my other x for the units. I am going to distribute the x through, so that's going to be 10x minus 0.001x squared. And that's going to represent our revenue function. And as far as its domain, the domain is going to stay the same as what we've experienced before with that, because our x and p are still the same things. Okay, so I want to find the marginal revenue at each of these different values here. So our marginal revenue, marginal means derivative, so I'm going to take the derivative, so that's going to be 10 minus 0.00. I'm going to bring that 2 down and multiply it with the 1 that's already there, and I'm going to have 0.002x. So that's my revenue function. So to find the marginal revenue at each one of these, I'm just simply going to plug those into that revenue function. So if we look at this, okay, if I plug 2,000 into the revenue function, I'm going to have 10 minus this times 2,000, and that's going to give me 6. So for 2,000 being produced, the revenue increases for higher production. So looking at that, and I'll go ahead and pull the rest of these up. So you do need to state your level of production, because when 2,000 are being produced, we have a positive revenue, marginal revenue. So that means that the revenue is actually increasing if we increase production. At 5,000 being produced, it equals 0. Okay, so 0 is neither increasing or decreasing. So it's saying at 5,000 units, the revenue is not changing for higher production. Okay, so to produce more is not going to generate more revenue. And at 7,000 being produced, the revenue is negative. The marginal revenue is negative, which means that there's actually a decrease in the revenue for higher production. So the amount of revenue that we're getting is decreasing per item if we were to try to go beyond this 7,000. So at the point of 7,000, we're actually having a decrease in our revenue. Okay, if we graph these and find the points of intersection, you could definitely do this on your calculator. It's asking you to graph both the revenue and the cost function. So I would put one of them in for Y1 and one in for Y2. And as far as the window, you probably do need to make an adjustment on your window. If you look at what we're working with here on this graph, you can see it goes from 0 to 10,000. So this would be like your X minimum and your X maximum, and then this goes all the way up to 30,000, so that would be your Y max, and 0 is going to be your Y min. So that would set your window so that you see what we see here. And as far as understanding this, what we see is that the cost function is just a line, it's a linear function, and then the revenue is a quadratic function. So there are times when the revenue is below the cost, which means the company is taking a loss during that time. So this point is important to find. And then if we go on, we're profitable during this part here because the revenue function is above the cost function, so we are making a profit. We have another place where they equal each other. These places that they equal, revenue and cost are equal, is called a break-even point. So when we're at the break-even point, we're neither gaining or losing, basically, like it says, we're just breaking even. And then here, because the revenue comes down and the cost is staying the same, we have another place where we're losing money again. So we want to stay obviously between these two break-even points. So on your calculator, you can actually go to your second calculate menu and choose intersect. And it's going to ask you for your two functions. So you'll just like check and make sure that your first function, and it doesn't really matter the order of these, but one of your functions needs to be this one. The other function needs to be this. And then either type in 1,000 or move your cursor over to this point here and press enter. And when you do that, you're going to see that this is the point 1,000 and 9,000. And then if you come over to this point here, this is the point 7,000 and 21,000. Okay, so somewhere between 1,000 units and 7,000 units, the company would be profitable, but more than 7,000 or less than 1,000, it's not going to be profitable. Okay, so we're asked for this last part here to find and work with the profit function, its domain, and the graph. So the profit function we know is revenue minus cost. So we found, or we were given, depending, we found the revenue function here. We were given the cost function. So we actually need to subtract the two of these. We're going to take our revenue function, which is this, and we're going to subtract from it the cost function, which is this. Just be sure that you do put a set of parentheses here, okay? So we're going to distribute that negative through that parenthesis, and then we're going to combine like terms. So this would be my x squared term, and then I've got 10x and negative 2x will give me 8x, and then I've got the negative 7,000. So this is my profit function, okay? The domain for the profit function, if we're looking at the profit function here, since we had a domain for the revenue function of 0 to 10,000, then, and the cost function, the domain was anything greater than 0, then the domain for the profit function is kind of combining those two together and it being from 0 to 10,000. And so here we see the graph of the profit function, and you can tell this is where the profit 0, again, that's at 1,000 and 7,000. So the profit is above the x-axis for this part. And since it's above the x-axis here, we see that the company would be profitable between 1,000 and 7,000. Okay, the marginal profit, of course, we need to find the derivative of the profit function. So that's going to be negative 0.002x plus 8, and that's just taking the derivatives of each one of those terms there. And when we look at that, we need to plug these in. So we're going to plug in 1,000 for the derivative. Okay, and we're going to get 6 for that one. If we plug in 4,000, and I'm not going to go through all the steps for this one, but if we plug in 4,000, we're going to get 0. And if we plug in 6,000, we're going to get negative 4. So you can see that the profit is changing when we're producing 1,000 units. We have a positive marginal profit, which means the profit's increasing. Here at 4,000, the profit is not changing. It's at 0. So it's just kind of flat. And then here we've got the derivative of at 6,000 is negative. So we have a decreasing profit. All right, a few other things to keep in mind. We've got we have the function called average cost. So it's important to know what the average cost per unit or the cost per unit is, and that's just taking the cost, and this should not have this across it. So the cost function and dividing it by x. So the marginal average cost would just be taking the average cost function and taking the derivative of that. Same thing with average revenue. The average revenue is just the revenue divided by x. Marginal average revenue is the derivative of the average revenue. Average profit is just the profit divided by x. And the marginal average profit is the average profit, the derivative of the average profit. Okay, so if we want to find the average profit per unit if 1,000 dictionaries are produced, so we need to come up with the average profit, the average cost function here. So the average cost function is going to be 20,000 plus 10x divided by x, because it's always the cost function divided by x. So you don't technically have to go ahead and do this, but you're going to eventually need to do it. So you may as well just go ahead and break this apart. So I'm going to put 20,000 over x, and then I'm going to put 10x over x and simplify that. So this I'm going to write as 20,000 x to the negative 1 power. So I bring that up because I'm going to take a derivative. And then here I've just got, this reduces to be 10. Okay. All right, as far as the first one goes, we want to find the average cost if 1,000 dictionaries are produced. So we need the average cost at 1,000. So it doesn't really matter which form we use, but if we do 20,000 over 1,000 and then plus 10, okay, so this is going to be 1,000 goes into 20,000 20 times. Okay, so we're going to have the average cost per unit is going to be $30. So $30 per unit. All right, so we want to find the marginal average cost. So marginal tells us we're taking the derivative of the average cost. So average cost, we already determined that that function is 20,000 x to the negative 1 plus 10. So if I'm going to take the derivative of that, okay, so that means I'm going to have 20,000, I'll bring that negative 1 down, decrease my power by 1, and then the derivative of that is 0. Okay, so this is going to give me the marginal average cost function. If I need to know what the marginal average cost is at a production level of 1,000, I'm going to plug that into the derivative here. So I'm going to clean this up just a bit before we start plugging into it. Okay. So we'll have negative 20,000 over 1,000 squared. Which is negative 0.02. So at a production level of 1,000 dictionaries, we see that the average cost is decreasing. In fact, the average cost is decreasing by about 2 cents per dictionary. Okay, so at a production level of 1,000 dictionaries, each additional dictionary produced reduces the per unit cost by about 2 cents. Okay, so use the previous results to estimate the average cost per dictionary if 1,000 dictionaries are produced. So using the previous information here, the average cost for producing 1,000 dictionaries is about $30, and that's per dictionary. Okay, and if we want the average cost of per dictionary, if we're going to produce 1,001, and again, we're using what we've already found in this particular problem, we're going to say 30 plus the negative 0.02 is going to take us to 29.28, and that's going to be the average cost per dictionary for 1,001 dictionaries being produced, given that we're already producing the 1,000 dictionaries. So basically, this is your average cost. And again, that's specific to the 1,000, to producing 1,000 dictionaries. And this is your marginal cost, your marginal average cost. It's kind of hard to get all the words in there. All right, a couple of things just to remember. The marginal average cost function is computed by finding the average cost and second, finding the derivative. So don't switch the order on those, like don't find the derivative and then do the average. You've got to do the average and then the derivative, because it does create a totally different function. So there's two different interpretations for marginal cost function. First, the derivative The derivative is interpreted as the instantaneous rate of change in the cost function. So how fast is it changing at a particular time? But it's also an approximation of the exact cost of producing the X plus one item. Okay, the same interpretations don't necessarily apply to marginal average cost functions, but they do apply to your revenue and profit functions. All right, here's one for you to possibly pause and look at on your own that kind of summarizes the things we've looked at today. Okay, first, if we're going to find marginal cost function, marginal means take the derivative. So we're going to take the derivative of our cost function. So our marginal cost, which is the derivative of the cost, would be 600 minus 1.5x. So that would be part A. Part B, find the marginal cost at a production level of 200 transmissions per week. So we're going to take the marginal cost that we found here, and we're going to plug 200 into that, and we're going to find that our marginal cost is $300 per week. Okay, as far as interpreting these results, at a production level of 200 transmissions, the total production costs are increasing at a rate of $300 per transmission, and the 201st transmission is expected to cost about $300. Because again, the C prime or the derivative of your cost is an approximation for producing that next number of units. As far as the exact cost, to get the exact cost, you've got to calculate the cost for the 201st, subtract away the cost for the 200, and on this particular one, if you subtract those, you're going to find the exact cost is going to be $299.25. Using the marginal cost function, we can see that we estimated it to be about $300. Here, when we do the exact cost, we see that it's $299.25. So pretty close on the estimate there. All right, we've got another one here you can practice on. So the total cost of producing X bicycles is given by this particular cost function. So if we want to find the exact cost, we need to find the 141st, the cost for the 141st bicycles being produced, subtract the first 140, the cost for those, subtract those two, and we end up with the cost for producing the 141st bicycle. So this represents the cost of producing all 141, and this is the cost of producing all 140. So if you take those two away, if you subtract those two, then what you're going to see is that difference represents that just the cost of producing that one item there. Okay, use the marginal cost to approximate the cost. So we know marginal cost is an approximation for producing that. So what we need to do here is we need to find the marginal cost, which is the derivative of cost, and then we need to plug in the 140th, and that will give us an estimate of what it's going to cost to produce the next one, which is the 141st. Okay, so we'll find the derivative of this, which you can see here. Plug in 140, again, not 141, plug in 140, and we get $144.40 as our estimate. And again, our exact was, if we look back here, our exact was $144.38. So again, pretty close. Okay. If we want to find the marginal profit, we're given the profit equation on this one. So the profit equation, we need to find marginal profit, which is the derivative. So we'll take the derivative of this, and then we're going to plug in the 1,000, the 4,000, and the 6,000. And when we do that, we can see that we have a positive marginal profit at 1,000 units have 0 for marginal profit at 4,000, and we have -4 for the marginal profit at 6,000. So we have it's increasing, the profit's increasing at 1,000 units of production. It's flat, it's not changing at 4,000, and it's decreasing at 6,000. Okay, here we're given the cost function and the revenue function, and you're asked to find the marginal revenue and the marginal profit. So first off, if we're finding marginal revenue, we need to take the derivative. So if we take the derivative, we're going to see that we have this function here. We're going to plug in both 3,000 and 6,000 and interpret those. So if we plug 3,000 in, we get 4, and if we plug 6,000 in, we get -2. So when it's a 4 and it's positive, revenue's increasing because it's positive. So it's increasing a small amount at about $4 per headphone made when we're producing 3,000, in this case, headphones. Okay. So this one has a negative revenue. So revenue's decreasing because it was negative. So it's decreasing about $2 per headphone at the production level of 6,000. So when we're producing 6,000 headphones, we're losing about $2 in revenue per headphone made. Okay, if we're given the cost function, then we can find the profit. So profit is revenue minus the cost. So we put the revenue function in that we were given, put our cost function in, and subtract the two, and that gives us our profit equation. And then from there, if we need marginal profit, we're going to take the derivative and then evaluate it at the two values that are asked for, which is 2,000 and 7,000. So we get 4 for the marginal profit at a level of production of 2,000 and -6 at a marginal profit at a level of production of 7,000. So as far as interpreting these, again, because this is positive, profits increasing a small amount, about $4 per headphone made at a production level of 2,000 headphones. This one, 7,000, profits decreasing a small amount because it's negative at a production level of 7,000 headphones. You always have to include that at that production level so that we know where this is taking place, because it is instantaneous. It's not average or anything of that nature. Okay, if we look at this one, we're given the cost function and we're asked to find the average cost and the marginal average cost. So average cost, we always take the cost function, which are given here, and you divide it by x. So what we want to do is we're going to split this up. Okay, so I'm going to put the 7,000 over x, and I'm going to put the 2x over x, and then simplify those. It's going to be easier if we rewrite these, and this should be plus 2. Okay, so if I rewrite this will be x to the -1. And when we take the derivative of it, so this would be my average cost. So when I take the derivative of this that I've circled, the -1 is going to come down and multiply to the 7,000. So I'll have -7,000x and then decrease the power by 1. So I've got -7,000 over x squared, and that's going to be my marginal average cost. Okay, if we plug in 100 and for both the average cost and the marginal average cost, we can see that the average cost when we plug 100 in at a production level of 100 is 72. So what I would want you to say is, again, state your production level. So at a production level of 100 headphones, the average cost, which is what this gives me, per set is $72. Okay, so it's costing me about $72 per set. That's my average cost when I'm producing 100 headphones. Okay, here this is going to give me the marginal average cost. So the marginal average cost is about negative 70 cents. So at a production level of 100 headphones, state the production level. The average cost per set is decreasing because it's a negative marginal value. It's decreasing by about 70 cents. Okay, use the results in part B to estimate the average cost per headphone at a production level of 101 headphones. So basically we know that the average cost of producing 100 is 72, and then we know that the average cost is changing, decreasing by about 70 cents per item produced. So we're going to take the 72 for the 100 and we're going to subtract how it's changing, and we come up with $71.30 as the average cost per headphone when we produce the 101st headphone.